Hello, good morning, friend. Yes, morning to all. Equation for refraction and single spherical surface. Today our topic is refraction for single spherical surface. We so far studied refraction at plane surfaces, but same phenomena is available in spherical surface also. Sign conventions also same. There is no any change of single spherical surface also. But the two conditions. First, single spherical surface. We so far studying refraction and plane surfaces. But same phenomena available in spherical surface also. Sign conventions are same. There is no any change of single spherical surface. But two conditions. Yeah. Okay. First of all, studied in a single spherical surface. Consider one single spherical surface. This is a medium 1. This is medium 2. Refractive index of this medium is N1. Refractive index of this medium is N2. This is a principal axis. This is pole point O. The object is placed at the point object placed at point O. This is, well, the object distance. The distance between pole and the object is object distance. When the single spherical surface, the point object, the image fall on the spherical surfaces. The image is formed, well, the left side or other side. This is a incident ray when the point object incident on the surface of single spherical surface. This point is N. Well, angle of incidence, draw the normal line to the plane of the surface. The normal line is perpendicular to the tangent to the plane of the surface. Because, see, this is normal line. Well, angle between normal and the incident. This is angle of incidence. Angle of incidence. The normal line is perpendicular to the surface, tangent to the plane of the surface. That's why the normal line, any point on the surfaces, the normal line must be traveled. I mean the passing through the center of curvature of the spherical surfaces. This is center of curvature. Center of curvature. Well, the distance between pole and the center of curvature is, the distance between pole and center of curvature is radius of curvature. Radius of curvature. So I want to draw the normal line. After line, listen to me. The incident is the medium is 1, air medium. After air medium, just I want to take a reference medium R. This is a denser medium. First one is a medium 1. This is a rarer. This is medium 2. This is denser medium. When light transfer passing from rarer to denser, the refractive index of first medium is N1. Refractive index of second medium is N2. So the incident ray passing from rarer to denser after refraction. After refraction, well, rarer to denser after refraction is bent towards normal. Bent towards normal. Rarer to denser. bend towards normal. Denser to rarer, away from normal. So, after refraction, bend towards normal. As it is no well the medium of light transfer from rarer to denser. This is rarer medium, this is denser medium. Rarer to denser, after refraction is bent towards normal. Denser to rarer, denser medium to rarer medium, incident ray away from normal. This is angle of incidence, this is angle of refraction. This is angle of incidence, this is angle of refraction. Rarer to denser, bend towards normal, denser to rarer, away from normal. So this is rarer to denser, bend towards normal. And this is angle of refraction. Angle of refraction. This point is I. The image is formed at the point of I. The image is formed at this point. So that's why I want to take this as I. This is object O. I mean the center of the point, a spherical surface is the pole point, and the line passing through the pole, straight line passing through the pole is the principal axis. You know well. In our convenient, I want to take this angle NPO. NPO in reference almost said to be all values are measured from pole point. You know well, mirror and lenses also. All values are measured from pole point. This is very important. This is pole. This distance is simply slightly varying, but the point is almost equal at a minimum angle. I mean the very small angle. That's why this I want to draw the line in straight line. Point of P dash. See, P and P dash are almost equal for small angle. This is very important. This point. So P dash and P is almost equal for small angle. So the normal line drawn from N to P dash. N to P dash is a perpendicular line. It is a very important. Here consider P and P dash almost equal because of very small angle. The P and P dash is almost equal. So very important. Listen to me, all of you. I mean, this is angle of incidence. I mean, I want to make an alpha value. This angle is alpha. See, the two conditions are very important. First condition, the incident of light is almost parallel to the principal axis. Parallel to the principal axis. At the same time, the single spherical surface, the incident light is almost parallel to the principal axis. That is called as parallaxal axis. This is very important. See, alpha varying to almost equal to less than 0. That's why. So alpha is nothing but this angle NOP. Angle of NOP is equal to alpha. In our convenient, that's why NOP and P dash almost equal. You know well the sign conventions and values P and P dash, all values measured from pole point of the surface. See the angle NOP is alpha. And next one is in our convenient, I want to take this angle NCP. NCP is equal to beta. This is NCP is beta. And also angle NIP. NIP is equal to gamma. This is gamma. You know well angle of incidence I, angle of refraction R. Very smallest angle, alpha value is less than 0 when almost equal to, it's not equal to 1, almost less than 0 when. Because of the condition, first condition is the incident ray is almost parallel to the principal axis. For example, this is surface, this is incident ray, this is incident ray, this is incident ray, this is incident ray. At most smallest angle, the incident ray, normal point, this is P, and the P and P dash should be converged. I mean the same point. Consider same point at smallest angle of incidence. Angle of incidence, I mean smallest value. Alpha value is a very small means, and P dash is almost equal. So NIP is equal to gamma, and NCP angle beta, and NOP is the alpha. Very smallest angle. And next one is I want to calculate this angle of incidence. Angle of incidence. See the angle. See this angle of incidence. This is principal axis. Principal axis. This is incident ray. This is normal. I mean end point. This is end point. This is P. This is angle of incidence. Angle of incidence. This is alpha and point C. And point C. This is beta. So I want to calculate this angle of incidence. What is the angle of incidence? I is equal to alpha plus beta. The formula, mathematical formula, an outer angle is I is equal to sum of the opposite angles, alpha plus beta. But our proof is that what is this? Alpha means this angle is 90 degree. But general formula I is equal to alpha plus beta. I want the proof. See, alpha, this is alpha, N, O, P, alpha, N, C, this is C, P, beta, this is N, P, O is 90 degree. What is this? 90 minus alpha. And N, C, P is beta means this is 90 degree. What is this? 90 minus beta. So far overall angle this is 180 degree. So I plus 90 minus alpha plus 90 minus beta, which is equal to 180 degree. In our textbook, I is equal to alpha plus beta is a direct value, but the direct value is equal to proved by this angle. See, this diagram is a very important diagram 1. So I, this value is I, this is 90 plus 90 minus alpha, this is 90 minus beta, which is equal to overall angle is 180 degree. So 90, 90, 180 cancel. I is equal to this minus value goes to other side. So positive alpha, I mean this is also negative value goes to other side. So I is equal to alpha plus beta. This is equation number 1. And next I want to calculate this beta value. What is this beta? See diagram. NCP is a beta value. NCP is beta. Beta is equal to another one angle. Just I want to make this reference angle C. Is a N value, this is P point, this is alpha, this is angle of incidence, point is C, this is beta, and this is image is formed at the point, this is I, this is R value, this is gamma. I want this beta triangle NIP, triangle NIP, see this. This is beta and this is R value, this is gamma value. I mean this point is N, this point is I, and this point is C. So beta value is equal to, what is beta value? Beta is outside angle which is equal to sum of the inside angles R plus gamma. R plus gamma. But I want the R value. Sorry, R value. R is equal to beta minus gamma. This is beta minus gamma. Prove this. Where is comes from this? This is just I want to take this x value. So the sum of the three angles is equal to 180 degree. R plus gamma. R plus gamma plus x equal to 180 degree. Is equal to 180 degree. R plus gamma plus x is equal to 180 degree. So here is x is equal to 180 minus R. minus gamma. 180 minus r minus gamma. So x value. But summation of x plus beta is equal to 180. So beta plus x is equal to 180. So substitute the value of x here. See this, beta plus what is x value? X is equal to 180 minus r minus gamma, which is equal to 180. So 180 cancel. So beta, which is equal to r plus gamma. See, the negative value goes to other side positive. This also goes to other side positive. Beta is equal to r plus gamma. So r is equal to beta minus gamma. Beta minus, what is I value? I value is equal to alpha plus beta. This is equation number 2. This is equation number 2. What is R value? Beta minus gamma. This is equation number 3. And alpha is equal to, sorry, equation number 1 and equation number 2, both are equal. So equation number 1, alpha plus beta, and beta is equal to r plus gamma. R is equal to beta minus gamma. I want to take the, according to Snell's law, angle of incidence. Sine of angle of incidence, sin I by sin r is equal to refractive index of second medium with respect to first medium. Refractive index of second medium with respect to first medium. See, when light travels from one medium to another medium, this is air medium, this is denser medium. The refractive index of first medium is n1, refractive index of second medium is n2. According to Snell's law, second medium with respect to first medium. Second medium with respect to first medium, I mean n2. Second medium with respect to first medium, which is equal to n2 divided by n1, which is equal to sin I divided by sin r. Sin I divided by sin r. So I want this is simplified this equation. See this, cross multiplication. N1 sin I equal to N1 sin I equal to N2 sin R. This is equation number 3. So N1 sin I is equal to N2 sin R. See, very smallest angle, the spherical equation for refraction at a single spherical surface, the two conditions are very important. What is the first condition? The incident light is monochromatic. The incident light is monochromatic light. What do you mean by monochromatic light? It is a single wavelength. There is no any change, single color only. Single wavelength, monochromatic light. Second one is the incident light is almost parallel to the principal axis. The incident light is almost parallel to the principal axis. This is a incident light. This is a principal axis, point P, almost parallel to the principal axis. Almost parallel to the principal axis. First condition. Which means, what is the condition almost parallel to the principal axis? Means alpha value is very low value. That's why smallest angle. I want to consider the very smallest angle. So angle of incidence and angle of refraction is also very small value. That's why sin theta, very smallest value of sin theta, which is equal to theta. Very smallest value of sin r is equal to r. So that's why I want to change in our continuity. N1 sin I is equal to I, which is equal to N2 into sin r equal to r. Smallest angle. This is the main equation. N1 I equal to N2 R. Equation number 4. See, first one, angle of incidence. I want to measure the angle of incidence. I is equal to alpha plus I is equal to alpha plus beta, and beta is equal to R plus gamma. The angle of refraction R is equal to beta minus gamma. Beta minus gamma. So see this angle of according to Snell's law, second medium with respect to first medium. So n2 divided by n1 equal to sin I by sin R. So n1 sin I equal to n2 sin R. So n1 I equal to n2 R. N2 R. Just see the diagram. So I want to make to one tan alpha, tan beta, and tan gamma value from this diagram. See this. This is IONOP, angle NOP. What is the tan value? Angle NOP. Tan alpha is equal to tan alpha is equal to angle NOP. Angle NOP. Tan alpha. This is NON. This is P. Alpha. What is the tan alpha? Tan alpha is equal to opposite side Pn divided by adjacent side PO. Tan alpha is equal to Pn divided by PO. And angle NCP. NCP. Beta value. Tan beta equal to. What is tan beta? Which is equal to Pn divided by PC. Pn divided by PC. And angle NIP. Angle NIP. Angle NIP equal to tan gamma equal. Tan gamma which is equal to Pn divided by Pi. Pn divided by Pi. See, very important tan alpha, tan beta, and tan gamma value. Because of I substitute the value in equation number 4. I1 N1 I equal to N2 R. So tan alpha equal to Pn divided by PO, tan beta is equal to Pn divided by PC, tan gamma is equal to Pn divided by Pi. See, very smallest and very smallest incident ray when alpha value is very small means almost well tan theta which is equal to theta. Tan theta which is equal to theta. That's why our in convenient alpha is equal to Pn divided by PO. Tan alpha is equal to, see this, what is this? Tan alpha is equal to Pn divided by PO. So alpha is equal to Pn divided by PO. Pn divided by PO, and beta is equal to Pn divided by Pc. And next one is gamma is equal to Pn divided by Pi. The smallest value. If tan theta is equal to for smallest angle, tan theta is equal to theta. For smallest angle, sin theta is equal to theta. Well, alpha value, beta value, and gamma value. All values substituted in the equation number 4. According to Snell's law, N1I is equal to N2R. So I want to substitute it. What is N1 is the refractive index of medium 1. So N1 into I. What is I value? I is equal to, well, I is equal to alpha plus beta. What is R value? R is equal to, see this diagram, what is R value? Value is equal to beta minus gamma. R value is equal to beta minus gamma. These values substitute in equation number 4. N1 into I. N1 into I. What is I value? Alpha plus beta. N1 of alpha plus beta. Alpha plus beta, which is equal to N2. Refractive index of second medium into R. R is equal to beta minus gamma. Beta minus gamma. Multiple this. N1 alpha plus N1 beta, which is equal to N2 beta minus N2 gamma. N2 gamma. So rearrange the equations. N1 alpha, this negative N2 gamma goes to other side plus N2 gamma, which is equal to N2 beta. This is positive value goes to other side negative minus N1 beta. N1 beta. So N1 alpha plus N2 gamma, which is equal to common factor beta. So N2 minus N1 of beta. What is the alpha, gamma, and beta value? Substitute this. Alpha is equal to. Alpha is equal to. What is alpha value? Pn divided by Po. Pn divided by Po. What is beta value? Beta is equal to Pn divided by Pc. Pn divided by Pc. What is gamma value? Gamma value is equal to Pn divided by Pi. Pn divided by Pi. This substitute the values of alpha, beta, and gamma. See, this is alpha and beta gamma value. This is alpha is equal to Pn divided by Po. Beta is equal to Pn divided by Pc, and gamma is equal to Pn divided by Pi. So this is alpha, beta, and gamma. Substitute the values. Convenient. I want to substitute this. N1 into what is alpha value? Alpha is equal to Pn divided by P. Pn divided by Po plus N2 into gamma value. Pn divided by Pi. Pn divided by Pi, which is equal to N2 minus N1 of beta value. Beta is equal to Pn divided by Pc. Pn divided by Pc. So the common factor of Pn is both sides a common value Pn. So the value should be cancelled. But because of this is Pn value is common for two factors. So Pn of, just I want to take Pn of common. N1 divided by Po plus N2 divided by Pi is equal to N2 minus N1 of Pn divided by Pc. So Pn cancel. The remaining factors. What is this remaining factors? N1 divided by Po. N1 divided by Po plus N2 divided by Pi, which is equal to N2 minus N1 whole divided by Pc. See, this is a final equations of refraction of single spherical surface. I want to this. What is the diagram? See this. I want to measure the PO value and PI value. See this. Sorry, just I want to this. What is a PO? Who is this PO? See the diagram. PO is nothing but this is a object distance. PO is nothing but this is object distance. See P to O, pole to object. This is object distance. So that's why I want to substitute the value of N1 divided by PO. PO is the object distance. See, very important in sign convention is a very important this region. Just I want to take this, a pole is the center point of axis. This is x coordinate, this is x dash coordinate, this is y coordinate, this is y dash coordinate. You know well the position of the object is always left side of the mirror or left side of the lens or left side of the spherical surfaces. So u value is always negative. U value is always negative. Just I want to take the PO is nothing but this is object distance u. Object distance u. But the u value is negative according to sign convention. And plus N2 divided by PI. Who is this PI? PI is nothing but principal. I mean, pole to image. The distance between pole and image is image distance V. Image distance V. This value is placed in the x coordinate. So V value, I mean the x coordinate means V value is a positive. That's why N2 divided by PI. PI is nothing but this is image distance. You know well the definitions of image distance. Distance between pole and image. This is pole point, pole to image. So that's why PI is nothing but this is image distance V, which is equal to N2 minus N1 divided by use is PC. PC. This is a spherical surface. This is spherical surface. Incident spherical surface is C pole to C. This is a radius of curvature of spherical surfaces. Radius of curvature of spherical surfaces. That's why P is nothing but this is for radius of curvature of spherical surfaces. So PO is a object distance. So object distance value is negative according to sign convention. PI is the image distance. This image is formed in other side. That's why because of the medium the object image is incident fall on surface rare to denser. That's why rarer to denser after refractions bend towards normal and insert the point of I. So V value is positive. That's why the value is rearranged this. The equation should be rearranging. Now I want to take this N2 divided by V minus N1 divided by U. This value is negative. That's why minus N1 divided by U, which is equal to N2 minus N1 divided by R. R is nothing but this is a radius of curvature. This is equation of spherical surface, single spherical surfaces. Single spherical surface. I mean equation for refraction at a single spherical surface. It's very important. This is related by refractive indices and object distance, image distance, and radius of curvature also. It's a very important equation for single spherical surface. The equation for refraction at a single spherical surface. N2 divided by V minus N1 divided by U equal to N2 minus N1 divided by R. Who is N2? N2 is the refractive index of second medium. V is the image distance. N1 is the refractive index of first medium. U is the object distance. N2 minus N1 divided by R. R is the radius of curvature of spherical surfaces. Radius of curvature of spherical surface. This is equation for refraction at a single spherical surface. For First of all, draw the diagram. I give you one more once again, listen to me. This is important area, that's why consider single spherical surface as single spherical surfaces. I mean the light incident or I mean point of the incident on the surface. I mean the point is n, draw the normal line to the spherical surface. So this is normal means this is angle of incident ray and the normal angle of incidence. This is angle of refraction. This value is alpha. This is beta. This is gamma. First of all, Snell's law. What says Snell's law? Second medium with respect to first medium, n2 divided by n1 is equal to sin I divided by sin r. So n1 sin I equal to n2 sin r. n2 sin r. What is n1 refractive index of first medium? What is n2 refractive index of second medium? What is I angle of incidence? Angle of incidence. So R is the angle of refraction. So for smallest incident ray, this is condition and condition of single spherical surface. Equation for refraction single spherical surface. The incident ray is a very small. I mean the alpha value is very small. What is the meaning? This alpha value small means the incident ray almost parallel to the principal axis. Almost parallel to the principal axis for small value. So the alpha and beta and gamma values are very small. So I want to calculate this tan alpha, tan beta, tan gamma, tan alpha, tan beta, tan gamma. So the smallest value, I mean tan alpha is equal to alpha. For small value, tan alpha is equal to alpha. For small instant, small angle, sin theta is equal to theta. Is equal to theta. That's why this is base condition. Another one condition is incident light is must be monochromatic. Second one is the incident light is almost parallel to the principal axis. These are two conditions of this equation, Megan equations. So the final equation, Snell's law basis n1 sin I equal to n2 sin r. So n1 I which is equal to n2 r. This is basic information. Just I want to calculate this I value. What is I? Angle of incidence. I is equal to make an angle NOP. See this. I is equal to alpha plus beta. Alpha plus beta. And what is R value? R value is angle of refraction. R value is equal to. See this. R value is equal to beta minus gamma. Beta minus gamma R value. So I know I value, R value. To substitute the Snell's law n1 I is equal to n2 R. So I value R value substitute this. These values substitute in Snell's law equations n1 I equal to n2 R. Finally, you get the value of equations of refraction, single spherical surface, single equation of refraction and single spherical surface, n2 divided by V minus n2 divided by U is equal to n2 minus n1 divided by this is the final equations of refraction for equation for refraction at a single spherical surface. This is equation. Just next one, in our textbook, I give you one more example in the textbook. So what is solve this in this equation where we are using to find the position of object, position of image, and nature of image. In our textbook problem, almost example 6.12. 6.12. To find position of image and nature of image also. Position of image and nature of image. C to find position of image and nature of image. In our textbook diagrams, it is consider this is one refracting surface. This is medium is n1. This medium is n2. This medium is n2. I mean the next one is this principal axis. This point is pole P, and the object distance is 15 centimeters. When the object is placed at this point, this is object distance between pole and the object is 15 centimeters. 15 centimeter. And the C point, this is center of curvature of cervical surface. This is so distance between pole and the center of curvature, which is equal to 30 centimeter. 30 centimeter. The refractive index of first medium is R. Second medium is, I don't know this, but the refractive value is equal to 1.5. 1.5 means is a glass. So L1 is equal to 1 means the medium is R. R medium. So what is the refraction? See this. To find the position of object and the image. The equation is say refraction. So equations of refraction. What is the formula? N2 divided by V minus N1 divided by U is equal to N2 minus N1 divided by R. This is a formula. Textbook problem. This is M1 equal to refractive index 1, N2 is equal to 1.5, object distance is equal to 15 centimeter. I mean, this is the distance between an object and pole. Its value is U. U is equal to 15 centimeter. Distance between pole and the C is a radius of curvature R. First of all, apply sign convention. U value is equal to N1 equal to 1 because of reference medium. This is R medium. And the N2 is equal to 1.5. And what is object distance? Object distance is equal to minus 15 centimeter. It is a very important. Most of the students are making mistakes in this region. According to sign convention, the U value, object is always placed left side. You know well, all U value is always negative value. I mean this right to left. So that's why negative value U is equal to minus 15 centimeter. And R value is equal to x coordinate. I mean, consider this is point, this is x coordinate, this is x dash coordinate, this is y dash coordinate. So R value, radius of curvature, R is equal to 30 centimeter. R value is equal to 30 centimeter. Substitute the value in formula. What is this? N2 value is, what is this? N2 value. So N2 is equal to 1.5. N2 is equal to 1.5 divided by V. I don't know this. I want to calculate the position of image. V is equal and minus N1 value. What is N1 value? 1 divided by U value is equal to minus 15. Minus 15, which is equal to 1.5 minus 1 divided by R. R is equal to positive value. So plus 30 centimeter. Plus 30 centimeter. So 1.5 divided by V. 1.5 divided by V. This is negative value. This is also negative. So negative, negative, positive 1 divided by 15. Which is equal to 1.5 minus 1 is equal to 0.5 divided by 30. 0.5 divided by 30. So 1.5 divided by V, which is equal to this value, simplify this 5 divided by 300. 0.5 divided by 5 divided by 300. Cancel this. 0.5 divided by 30 multiple 10 divided by 10. So 5 divided by 300. So this is 1 time 6 time, which is equal to 1 divided by 60. So it is equal to 1 divided by 60. 1 divided by 5 v is equal to 1 divided by 60 minus 1 divided by 50. The positive values goes to other side is a negative. So 1 divided by 60 minus 1 divided by 50. And 1.5 by v equal to LCM. Yes, I want to take 60. 1 minus 4 times. 4 times of 15, 16. So which is equal to minus 3 divided by 60. Cancel this 1 time, this is 2 times. So which is equal to minus 1 divided by 20. So 1.5 divided by v, which is equal to minus 1 divided by 20. Multiple this v minus v is equal to 1.5 into 20. So which is equal to 1.5 into 20 is a 300 point decimal cancel. So it is equal to 30. So minus v is equal to 30. V is equal to minus 30 centimeters. V equal to minus 30 centimeters. V minus 30 centimeter means what does it mean? V value is negative. Because V value negative means the image is formed at the same side. See this. V value is 30, negative 30. Light incident is your incident. And also refractor, there are two denser, the refractor. This is also principal axis. Two rays is parallel. So the incident ray image is formed in the same side. This is the principal axis. This is image formed at the same side. This is image. So the value is 30 centimeter. 30 centimeter. Same side. Image is formed in same side. And left side of the spherical surface. Negative value. I give you one more clue word. If U value and V value same side means sign. Same side means the image is virtual. And U value and V is opposite side means the image is real. Just memorize this. The exam point of view. The exam point of exam view. So very important. U V same side means the image is virtual. U and V is opposite side means image is real. And the first example is completed. I give you another one example. Is to find position of object. To find position of object. Sorry, position of image on spherical surface. One spherical surface. The medium refractive index of medium is equal to 1. The refractive index of medium, this is N2 is equal to 1. This is example 2. 1.5. This is principal axis, pole point. The object is placed in this point. The distance between pole and object distance is equal to 30 centimeter. 30 centimeter. The radius of curvature is C point. C point. The distance between pole and the sea, you know well, this is equal to 10 centimeter. To find nature of position of image and nature of image. Position of image and the nature of image. Position of image and nature of image. You know well, N1 value and N2 value and object as U value and R value. It is as it is, just use the formula. What is the refractive index of first medium? N1 equal to 1 and N2 is equal to 1.5 and U value is equal to object distance. U is equal to minus 30 centimeter. Minus 30 centimeter. And R value is equal to, what is R value? R is equal to plus 10 centimeter. Image sign convention is a very important in this region. If you are doing any mistakes in this region, overall answer should be collapsed because of virtual image is converted to real, real is converted to virtual. What is this formula? N2 divided by V minus N1 divided by U is equal to N2 minus N1 divided by R. N1 divided by R. This is the formula of equation for refraction single sphericals. What is the question? What is the position nature of image? See, I want to calculate the V value. V is equal to, substitute the values. What is N2 value? N2 value is 1.5 divided by V minus, what is N1 value? N value is equal to 1 divided by U. U is equal to minus 30. U is equal to minus 30, which is equal to N2 1.5 minus 1 divided by R. R value is plus the 10 centimeter. So it is equal to, simplify this, very easy, but we are doing some mistakes in the sign convention. So 1.5 divided by B. So negative, negative, positive, plus 1 divided by 30, which is equal to 0.5 divided by 30, which is equal to 5 divided by 100, which is equal to just 21 divided by 100. See this 1.5 by V, 1.5 by V plus 1 divided by 30, which is equal to 1 divided by 1 divided by 20. So what is this? Simplify. I want to calculate the V value. V is equal to 1.5 by V is equal to 1 divided by 20 minus 1 divided by 30. So where the positive value goes to the other side, the negative. So which is equal to 30 minus 20 all divided by 600. 30 minus 20 is equal to 600, which is equal to 30 minus 20 divided by 600. Just cancel this, which is equal to 1 divided by 60. So 1.5 by V equal to 1 divided by 60. So V is equal to 1.5 into 60. What is the value? Is equal to 90. 990.0. So V is equal to 90 centimeter. Plus 90 centimeter. V plus 90 centimeter means what is this? The real image form. Where it form? The real image is formed. Listen to me. See the diagram. V is equal to 90 centimeter. If the U value is equal to 30 centimeter, the object is incident and refracted at this image is formed here 90 centimeter plus 90 centimeter plus 90 centimeter. The image is formed on the other side, I mean right side of the spherical surface. First example is negative value, virtual image. The second example is plus 90 centimeter. So real image is formed. Real image is formed. In nature of image is real. Position of image is plus 90 centimeter. I mean, this is refracted image value. This is a principal axis to our meet this point. So the image is formed at the point of height, a distance of 90 centimeter. And I give you one example. Say answer anybody want. Example 3. This is refracting surface. This medium is first medium. N1 is equal to 4 by 3. 4 by 3. And this is second medium. N2 is equal to 3 by 2. 3 by 2. Principal axis. This is point is pole point. The object is placed at a distance of 20 centimeter. 20 centimeter. And the radius of curvature of the object is C. This is 10 centimeter. 10 centimeter. I want this. What's the option? Position of image and the nature of image. I mean, position of image and nature of image is 30 centimeter real. First option. Second option is 60 centimeter virtual. And third option is 30 centimeter virtual. And the fourth option is 60 centimeter real. Which one is correct? Okay, students. Say any one of what is the correct answer? N1 equal to 4 by 3, N2 is equal to 3 by 2, and the image is object is formed at U value is equal to 20 centimeter. Radius of curvature is 10 centimeter. Anyone? Hello? Ravindranath.
Sir.
The students, do you receive my voice?
Yes, sir.
Anybody?
Sir, 30 centimeter.
Sir,
30 centimeter virtual, sir.
Hello?
Virtual.
Sir, 30 centimeter virtual, third option.
My voice. Hello, students.
Yes, sir.
Yes. What is the answer?
30 centimeter virtual.
30 centimeter virtual.
30 centimeter.
Virtual.
Very good. See, what is the formula? The formula N2 divided by.
30 centimeter.
Okay. Now, first of all, what does N2 value is? What does N2 value? See, 3 by 2 the formula. N1 is equal to 4 by 3. And U value is equal to minus 20 centimeter. And R is equal to 10 centimeter. Okay. Now, first of all, just N2 value is. What is N2 value? Please, students, please mute yourself. And 1 is equal to 4 by 3. And U value is equal to minus 20. So, what's the formula? N2 divided by V minus N1 divided by U is equal to N2 minus 1 divided by R. Okay, students. N is equal to 3 divided by 2. So it will be minus N1 equal to 4 by 3. 4 divided by 3. 2 value is minus 20. N2 3 divided by 2 minus 4 by 3 whole divided by R value is 10. Hello students, please mute yourself, all of you. Okay, give you answer. So 3 by 2b minus 4 divided by 3, u value is negative, so minus 30, which is equal to 3 by 2 minus 4 by 3 whole divided by radius of curvature is 10. So 3 divided by 2b negative, this is also negative. This is 5. Okay. You answer 2 divided by 3 by 2b minus 4 divided by 3. U value is negative 15. Equal to 3 by 2 minus 4 by 3 whole divided by radius of curvature is 10. So 3 divided by 2b negative. This is also negative. So it's one value. This is please all of you. 4 by 3. What is our new value? N1 value is equal to 4 by 3. This is 1 time. This is 5 times 1 divided by 15, which is equal to this is 9 by 9 minus 8 whole divided by 6. 60 into 10, which is equal to 1 divided by 60. 3 divided by 2b, which is equal to 1 divided by 60 minus 1 divided by 40. What is our value? This is 1 time, this is 5 times 1 divided by 15. This is 9 by 9 minus 8 whole divided by 60. 60 10 is equal to 60. 3 divided by 2b, which is equal to 1 divided by 60 minus 1 divided by 40. And last example, give one more example, last one. The dust particle. The dust particle. Last example, give one more example, last one. The dust particle. A dust particle is inside a spherical of refractive index 4/3. Where does it appear to an observer outside the sphere? This is a very important question. Where does it appear to an observer? To an observer outside the sphere. See, it's a very important question. Consider one spherical. The center of sphere is C. I mean, the radius of curvature of sphere is 15 centimeter. This is 15 centimeter. I mean, this is also 15 centimeter. The object is placed at the center of curvature from here, object, in distance of 5 centimeter. Distance of 5 centimeter. So this is 10 centimeter. I mean, this point is considered pole. Point is pole. This is center of curvature. Distance between this is 5 centimeter. The object is placed from pole is 10 centimeter. Overall radius of curvature is 15 centimeter. 15 centimeter. The refractive index of medium is this is N1, which is equal to 4/3. This is N2, almost equal to air. Refractive index of air is equal to 1. Consider the medium. The observer placed in the outside. See, see this. What is the U value? First of all, I want to calculate this. N1 value is equal to 4/3. N1 is equal to 4/3 and comma N2 is equal to 1. What is U value? U value is from pole point. This is equal to object space in this point. I mean, from 5 centimeter distance from center of curvature. So overall curvature is equal to 15 centimeter. So object value is U value is equal to minus 10 centimeter. Minus 10 centimeter. What is the radius of curvature? R is equal to radius of curvature. Consider this is pole point. This is x coordinate. This is x dash coordinate. And this is y coordinate. This is y dash coordinate. So R value is equal to minus 15 centimeter. Minus 15 centimeter. So what is the position of object? To find the position of object and the position of image. And just I want to take this. Listen to me. What is the formula of N2 divided by V minus N1 divided by U is equal to N2 minus N1 divided by R. N2 minus N1 divided by R. Substitute the value n2 value is, what is the n2 value? N2, the object placed, the observer placed at medium of outside is the air medium. So n2 value is equal to 1. 1 divided by b minus n1 value is 4 by 3. Almost this is a water surface. You know well, 4 by 3 is equal to refractive index 1.33. 1.33 means water surface. So n1 is equal to 4 divided by 3 of u. What is u value? U value is equal to minus 10. U value is minus 10, which is equal to 1 minus 4 by 3 whole divided by r value is equal to minus 15. Minus 50. So 1 by b, negative, negative, so positive plus. This is 2 2s are 4, 5 2s are 10. So 2 divided by 15. 2 divided by 15, which is equal to LCM 3 minus 4. 3 minus 4 whole divided by 3 of minus 15. So which is equal to minus 1 divided by minus 45. Minus 1 divided by minus 45, which is equal to negative, negative cancel. So 1 divided by 45. 1 divided by 45. Say this is, what is this? 1 by b equal to 1 by 45 minus 2 divided by 15. Minus 2 divided by 15. So 1 divided by b, which is equal to, yes, I want to take 45 minus 1. This is 1 value. This is 3 into 45 minus 3 into 3, 45. 3 into 2, 6, which is equal to minus 5 divided by 45. So which is equal to minus 9 times. So minus 1 divided by 9. Minus 1 divided by 9. So 1 by b equal to minus 1 by 9. So minus b is equal to 9 centimeter. B is equal to minus 9 centimeter. Which means b equal to minus 9 centimeter means, so virtual image. See diagram. This is position of object, incident, inside the surface. This is a denser medium. This is rarer medium. You know well, the ray passing from denser to rarer after refraction, then away from normal. Then away from normal. So this is image is formed at this point. This is. So pole point to object 10 centimeter. The image is formed at this is same side 9 centimeter virtual image. 9 centimeter virtual image. This is a very, very important. Out of surface, this medium is water medium because of refractive index is 4 by 3, 1.33. In the object placed inside of the water medium, the outside, the observer seen outside of sphere, the bubble, inside of the bubble, the object placed in the 9 centimeter distance. 9 centimeter distance. Same side is a very, very important visual image. Visual image. Very good. Okay, friends. This is completed. Once again, equation for refraction. I'll give you one more explanation. Loss. See this equation for refraction at single spherical surface. First of all, draw the diagram, alpha value and beta value and then gamma value also. So measure alpha value and then beta value and then gamma value. Alpha is equal to Pn by Po. The beta value is equal to Pn divided by C. tan alpha, tan beta, and tan gamma value. So NOP alpha values, NO angle NOP alpha, NCP beta, NIP gamma, alpha beta gamma value, and tan alpha, tan beta, tan gamma, and finally angle of incidence I is equal to alpha plus beta, and R value is equal to beta minus gamma. So the substitute the values of alpha, beta, gamma values. So get the equations, final equations. N2 divided by, see this, Snell's law, according to Snell's law, N1 sin I is equal to N2 sin R. N1 what smallest value sin theta value goes to theta, and N2 value, this is sin R, is goes to R value. Substitute the value of I and the value of R. I value is equal to alpha plus beta, R value is equal to beta minus gamma. So substitute the values, you get the final value N1 divided by PO, and N2 plus N2 divided by Pi is equal to N2 minus N1 divided by PC. What is PO? PO is nothing but is the object distance, and Pi is nothing but Pi is the image distance, and PC is nothing but this is radius of curvature. Substitute the value, get the final equation N2 divided by P minus N1 divided by U, and is equal to N2 minus N1 divided by R. This is the equation of refraction at a single spherical surfaces. And our more example 1, 2, 3, 4 examples are worked out. So just practice in this region. Okay, students. We will be in next class. Thank you to all.